Yesterday I asked you to complete problems 2, 7, and 8. Okay? And then, and 9 and 10, excuse me. And then I asked you to look up what coterminal angles were, and if you could, try those problems there. So, continuing information about the unit circle and radians, right now, I want you to tell your neighbor what you came up with on those problems, compare answers, and then explain to them what you believe coterminal means. So, negative 750 degrees, let's start with that. In standard position, meaning you start right here, and since it's negative, you're actually going downward. Okay, so you go around, there's 360, and you keep going around, there's 720, and another 30 degrees is 750. That is negative 750. Oops, not 75. 750. Which is the same thing as negative 30 degrees. Or it would be the same location as negative 30 degrees. Now, for those of you that have your graph done here, and you've done this, you like got all goofy with it in terms of your spiral. Let's make a neat spiral. Spring looking. Okay? Alright. Yeah, I don't know what it is. This is bad. We frown on it. Okay? Yes?
Do we have to draw the spiral, or can we just draw the line?
Nope, got to draw the spiral. Okay? Shows how many times you've rotated. Dude, that's look like a mean mat or a mean set. Here, hold on. I'm not a good drawer.
Are you drawing tears?
There you go. It's crying. Okay.
It's like a frog.
Yeah, now it's a frog. All right. Obviously, I am a math teacher, not an art teacher. Okay, number 7. Convert the angle or the degree measure to radians. I'm going to just have you check your work here. Hopefully you matched up with your neighbors, but I've got my work shown. So, here's number 7. So you 3 pi over 10. Notice you're doing pi over 180 equals x over 54. Okay, cross multiply. 54 pi equals 180x, and then divide by 180 and reduce. Make sure to reduce. Number 8, do it the same way with negative angles. You just put a negative degree in. Cross multiply and divide and reduce there. Yeah.
Can we do decimal for radians?
No. No, we'll keep it in fraction. Yeah.
I was going to ask, can we put it in like the fraction form where you remove the 18, you have negative 1, and then you put number 8 in there?
No, don't put it in mixed number. Yep. Leave it in improper fraction form. No decimals, no mixed numbers. Good questions. Number 9, 192 degrees. And number 10, negative 72. Guys, those are really good questions because I look at this and this is like my, I don't know, it's about at least my 10th time teaching it, or 20th time teaching it maybe. Okay, so if I don't address those little things that you guys ask, those are good questions to ask. If you have any pondering, I don't think of those questions every time. Okay, we good on those? All right. So what does coterminal mean? Matt, what'd you get? They have the same terminal point, yeah. Okay, they terminate at the same spot. So it's a standard. You're right. So it's a standard. It's an angle in standard position that terminates in the same location. Okay, so they both start at the initial side and then rotate to the same location. Yeah.
That be just like what we did number 2? Like you said, that
Yeah, very good example there. So negative 50 and negative 30 are coterminal. They end at the same spot. It's a very good way to think about it. In fact, negative 750, I think I said negative 50, and negative 750 and negative 30 are coterminal. Negative 30 and, in fact, if we went this way, 330 are coterminal. Okay? So really what you're doing is once you're here, you're just adding 360. You're adding a revolution, right? Or subtracting revolutions. You could just keep adding and subtracting. So like if I was at 55 degrees, you don't have to actually sketch it here, but if I was at 55 and I wanted a positive coterminal angle, well, I could just add 360 more degrees and get back to that point. So 55 plus 360, 415. That's a positive coterminal. There are an infinite number of positive coterminal angles. You just keep adding 360. For the rest of your life, you could keep coming up with coterminal angles. What a joy, man. Okay. Now, if you wanted a negative coterminal angle, you'd start here, and you go backwards 360, or subtract 360. So, 55 minus 360 will give you a negative one, which in that case, negative 305. That's a negative coterminal. And you can have an infinite number of those. You just keep subtracting 360. Yeah, it could be quite a hobby. Yeah. How fun. All right. What are you doing on tonight? Oh, I'm going to find some coterminal angles. All right. Very good. Everyone try number 4. Come up with a couple coterminal angles. One that's positive, one that's negative.
And if we did hold them last night?
If you already done them, then fantastic. See if you got them right.
How do you write it? Like, what form do you write the answer? Actually,
Just, no, just 415 and 305. No cool symbols, sorry. All right. Well, we could start with adding 360 to come up with a positive one. That would be 60 degrees. Now, sometimes, like on, well, let's finish this one. And then you could take negative 300 and subtract 360 to come up with a negative one. Any questions? Now, sometimes if, like on this one, if I subtract 360, did I come up with a negative one? No. I came up with another positive one. Well, that's good. If I want a negative one, I've got to subtract 360 again. All right. Coterminal is not a difficult thing. All right. All right. Questions? All right, man. Well, what I want you to do is let's go back to what we didn't talk about yesterday. That was this. Oh, sorry. Page 250 of your student journal. Besides the coterminal stuff, we already got that though. Okay? Page 250 of your student journal. I want to cover these two pieces. In fact, we kind of covered arc length. We just did it as when we did our introduction yesterday. Okay? So if I want to find the length of this arc, S is equal to radius times theta. Now please note that in here they say the arc length S and the area of a sector with radius R and a central angle. This is a huge statement right here. Theta, measured in radians. This works if you're measuring in radians. It doesn't work if you're not measuring in radians. If you're in degrees, this is not accurate. Okay? So if you're in degrees, what should be the first step? Convert to radians. That's why we went through that. Okay? So really all this is saying, right? Well, actually, you tell your neighbor what that actually, like in common words, what is it saying? Okay, don't just say the side or the arc length is equal to the rate. Okay, like come up with your own, like what does that mean? All right? Okay, let's go ahead and wrap up conversation. All right. Anyone want to tell me what they came up with? Like quick. No, I heard some big explanations, but yeah.
To find the length of that portion of the circumference, you multiply the radius by the angle measure of that pie chunk in radians.
Okay, good. To find this length, you multiply the radius by the angle measure in radians. Remember, a definition of a radian is how many radii fit around the outer edge. So if I am saying I am going to take however many radii, or radians it is, I'm multiplying the number of radians by the length of the radius. That's what you're doing there. So if I am saying the radius is 1, and I have 2 radians, an angle measure of 2 radians, then what's the length of that arc? It's 1 times 2. If I say, and now I'm trying to really make this pretty simple, if I say the radius is 2, and I have 4 radians, what's the length of the arc? 8. Now obviously that would be bigger, or that would be a good chunk of that circle, right? Because how much is one circle? 2 pi, which is approximately 6.28. Okay? So now usually the radian measure is not going to be a whole number like I've given you. I'm just trying to break it down to a simpler concept. Usually the radian measure is going to be like, hey, you have a radian measure of pi over 2 and a radius length of 4. What's the length of the arc? Well, it's 4 times pi over 2. 4 pi over 2, or 2 pi. Okay. We good? All right. Guys, this other one's a little more complex to come up with. Area is equal to 1/2 r squared theta. Now, this right here, how many of you remember finding areas of sectors last year in geometry?
Barely.
Anyone remember how to find the area of a sector? Like what our formula was? I will. No, it's not this, because we didn't measure in radians last year. That's a. How many of you remember how to find the area of a circle? Oh man! All right. Area of a circle. Okay, is pi r squared.
And then would you multiply it by
No, they're
the
not.
angle measure?
Pi around.
Then wouldn't you multiply it by the decimal value of the angle that you had?
Yeah, so then so that's the whole circle. If I want to find the portion of that circle, so for instance, let's just pretend we have a sector. Let's pretend that's at the center. And we have a sector that has a 90-degree angle. Now I'm in degrees here. So last year what you did is you said, okay, take pi r squared and I multiply it by the portion of the circle, which we did like 90 over 360, which everyone knows is 1/4. So you did 1/4 pi r squared. Okay, now how many of you remember it now? Okay, some of you can't. Who had me for geometry? You guys don't remember this? I am going to send you right back to geometry. You have to take all of it over again. All right. Zach, you remember it? Yeah. Oh, that was like a minute ago. Okay. All right. Well, if you can take that, this doesn't work as well if you don't remember it. If you can take that, and let's just say I am going to summarize this formula right here as that. Okay, portion of the circle times the area of the circle. Okay, the portion of the circle times the area of the circle. Now, when we're dealing with radians, we're not dealing with degrees here. We're dealing with theta. Okay, so if I say the portion times the area, we know this one, pi r squared. When I'm dealing with portion, I'm dealing with theta. And theta is a portion of how many radians? How many total radians are there? 2 pi. Everyone agree? Okay, so you're saying theta is a portion of 2 pi. Rather than it being a portion of 360, it's a portion of 2 pi. How many are following me? Okay, let's simplify that formula right there. Okay? It's good stuff. All right, how do I simplify? No, can't cross multiply.
Wait, you can
We cancel the pi. Good. Anything else? Nothing else. So what's my numerator? Theta r squared. What's my denominator? 2. What's another way of writing that? 1/2 theta r squared, which is, whoa, that's awesome. Except for theta's in the wrong spot. Jeez, hold on. Yes. No, it doesn't matter. You multiply in any order. Okay? There we go. Hey, that's how we get that. So you want to find the area of the sector. It's not magic. It's just when you're dealing with radians, there's a certain formula you can use. It's pretty cool. It's pretty rad. Okay? All right. Questions? How many think you got it? All right, good. All right, man. So that means we got to do this problem now. Oh, yeah. There you go. With your groupies. This is not in your book anywhere. Well, it's actually in your textbook, example 4. But you're going to have to copy it down somewhere. Hey, for those of you struggling, these are the things you're using. What we just talked about. You're finding the length of the arc. That's the length of the fence. And you're finding the area of the field, because that's a part of a circle. What is this is a 90-degree angle right here. It is a 90-degree angle.
No, wait.
Not yet? Close?
2 seconds.
1,
3 seconds.
2, 3, 4. Okay.
30 seconds. Well, I need like seconds. I can do it as long as like after I say 2 seconds, like a couple seconds after that.
Okay, S equals R theta. All right. So our arc length, S, is equal to the radius, 200, times theta. Well, 90 degrees is pi over 2. Remember, we talked about those yesterday. If you could not remember that, then you have to do your conversion of pi over 180 is equal to x over 90. So you get 90 pi, cross multiply, equals 180x. Divide each side by 180. You get x equals pi over 2. Okay? So it's times pi over 2. Which, when you multiply those, you divide here, or cross cancel, you get 100 pi. This length is 100 pi. Rounded to the nearest tenth, or actually, let's just go to the nearest foot. 314 feet. Okay? Yeah, that's what. Yeah. Area. Area is not, it's theta. Okay? Area is equal to 1/2. Good. 1/2, 200 squared. That's the radius. And then times pi over 2. So, 200 squared just happens to be 4 with 4 zeros. And pi over 2. Now, notice I can go 1/2 of this amount. I don't have to distribute it in. So it's like 20,000 pi over 2 times pi over 2. Then I can take another half of that, which is 10,000 pi. That's a lot of pies. Yeah. 10,000 pies, 31,416. We go to the nearest square foot. Questions? Okay, last piece, which was actually our warm-up today, which I didn't make you do as a warm-up. We are going to complete the unit circle. Now, we are going to completely complete the unit circle. So some of it will be a review. Some of it will be pretty new. I tried to foreshadow it yesterday. So first thing, label all degrees and all radian measures. Let's go radian measures on the inside, degrees on the outside. Okay? If you need help starting, remember, they give you this one. 180 degrees is pi radians. This is 30 degrees. This is 45 degrees, 60 degrees, 90 degrees. Okay? So as you're going through, you're counting 30, 60, 90, 120, 150, and then 0, 45, 90, 135. Okay, I'm going to let you keep going from there now. Okay, so 30, let's figure out all of our angles first. 180, 210. I'm just going to count by the 30s real quick. That helps me. 300, 330. Don't forget 360. Okay, and then 45, 180, 225, 270, 315, and 360. Now radians. If I'm going by 30s, this is pi. 30 is 1/6 of 180. Therefore, this radian measure has to be 1/6 of pi, pi over 6. And 60 is 2 pi over 6, which is pi over 3. Simplify it. And then 3 pi over 6, which is equal to pi over 2. And then 4 pi over 6, which is 2 pi over 3. Now at this point, rather than continually reducing, I'm going to start going, hold on, every 60, there's 1 pi over 3, 2 pi over 3. The next 60 is here, which is 3 pi over 3. The next 60 would be here, which would be 4 pi over 3. Another 60 would be here, 5 pi over 3. And then the last 60 would be here, 6 pi over 3, or 2 pi. And then my 30s, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6. We know 9 pi over 6 is pi over, or 3 pi over 2. And then 10 pi over 6 and 11 pi over 6. And then 12 pi over 6, which is 2 pi. Same thing as 12 pi over 6. Okay? Our 45s. 180, 45 is 1/4 of 180. So this has to be pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, we're just counting by 45s, 6 pi over 4, and 7 pi over 4. Those are your radian measures. Questions? How many of you understand the pattern? Okay, if you don't, you and I need to talk individually. You need to say, hey, I don't understand the pattern, and I'll sit with you and work through it. Okay? Now, the next piece is to find the coordinates of this point. That means the x, y values. Okay? So, what we're going to do is I'm going to have you draw in a radius. Just do your best straight line without a ruler. unless you have one sitting at your desk already. Type A people, you're going to have to breathe here. Okay? This is a unit circle, a 1 unit circle. That means this radius is 1. And I also know this is a 30-degree angle. And if I drop an altitude from this point down, I now have a right triangle. That is a 30, 60, 90. Okay, how many are with me? Okay, so in our 30, 60, 90, let's just go up here really quick, just off at the top or on the back of your paper, whatever. This is a 30, 60, 90. That is 1. We know that. That's what we know. Okay? Now if that's 1, in terms of our relationship here, this side, if we called this y, this would be y root 3, right? You guys remember all this? And this would be 2y. So what is this length? This is 1/2. What is this? 1/2 root 3, also known as root 3 over 2. Okay, now I'm going to go back here. Using that information, what I'm really saying is that this length right here is 1/2, and this length is root 3 over 2. Everyone agree? If I want to find this coordinate, well, the x value is from here to here, which happens to be root 3 over 2. And the y value is from here, well, here to up here, which is this same length as this, which is 1/2. You guys with me there? Okay. Any questions? Now, yeah, was there stuff on that? Is it? Yeah, it's right there. Okay. Now, if I'm dealing with this one right here, I'm going to skip 45 for a minute. I'm going to go up to 60. Okay. I'm going to draw my triangle in. Okay. Everyone good there? Now, notice, is this a 30, 60, 90 triangle? Yeah, it's just 30's up here now. And this is the 60. Which means what happens with these two values? Yeah, this length is now 1/2, and this is root 3 over 2. So my coordinate is 1/2 and root 3 over 2. All right. How many are with me? Okay. This last one, this last triangle, is a right triangle. However, this right triangle is now a 45, 45, 90. So if I go up here and I sketch in a 45, 45, 90 triangle with a length of 1, right there. And remember the ratio here, if this is x, this is x, this is x root 2. Well, how do I solve for x? Yeah, I get 1 equals x root 2. I divide both sides by root 2. I get x equals 1 over root 2, which we know as root 2 over 2. Now the good news, oops, not over root 2, so root 2 over 2. The good news about that is this is root 2 over 2, and this is root 2 over 2. Now, that means this length is root 2 over 2, and this length is root 2 over 2, which means this coordinate is root 2 over 2, root 2 over 2. Now, just out of curiosity, we almost have our full first quadrant filled out. What is this coordinate right here? 1, 0. And what's this quadrant, or what's this coordinate here? 0, 1. Now, I will tell you, given all of that information, you should be able to fill out every other coordinate without doing any calculations. Okay? Here's your hint. In this quadrant, what type of values do we have? Positive and positive. In this quadrant we have? Yeah, negative positive. X is negative, Y is still positive. In this one? Negative, negative. And this one? You should be able to fill out all those other coordinates now. Off you go. Okay, just so you know, here I'm just going to be switching things around, right? So my Y values stay the same because positive in this quadrant, positive in this quadrant. X values just flip signs. So rather than having 1/2, I have negative 1/2 now. And positive root 3 over 2. It's because X changed signs. Okay? Right across from it, I get negative root 2 over 2. And root 2 over 2. And negative root 3 over 2. And 1/2. And then down here, same thing. And these would actually go downward if you want to think of it like that. Those points. Okay? Alright, so this one right here is negative root 3 over 2 and negative 1/2. Negative root 2 over 2, negative root 2 over 2. And this one drops down, so we get negative 1/2 and negative root 3 over 2. This one, 0, negative 1. And then these can come across, or they could go down this way. You get a cool little pattern going there, however you want to look at it. This one would be positive 1/2 now, and negative root 3 over 2. Positive root 2 over 2, and negative root 2 over 2. And positive root 3 over 2, and negative 1/2. Right, any questions there? By the way, make sure you always fill in 360. It's still 1, 0. I know it's weird to have two values there, but one is for 0, and the other is for 360 degrees. Now, one of your quizzes will be making this all on your own, without any notes. Just so you know, everyone understood the Radiance pattern, right? There is a pattern for those values. This is how I start it. This one right here is 1, 0. Everyone got that? All I need to remember is 1 is, if I can remember, 1 is root 4 over 2, and 0 is root 0 over 2. If you can memorize that, your pattern's easy. Root 4 over 2 is 2 over 2, correct? And root 0 over 2 is 0. So I just count root 4, root 3, root 2, root 1, root 0. Those are my x values. Now, they're not simplified yet, all of them. This becomes, well, we'll get to that here in a minute. Okay, and this one I count upward. Root 1, root 2, root 3, and root 4. Now, if you can remember that, you know how to reflect them. All you have to do now is simplify. Root 0 over 2 is 0. Root 4 over 2 is 1. Root 1 over 2 is 1/2. That doesn't simplify, neither do those. This one is 1/2. You have your special values right there. Okay? How many understand that pattern? All right. That's the key to completing your unit circle. And the more you complete it, the easier those values will be to memorize. Okay? Just so you know, one last thing before we cut this off for today, because there's tons we can go on with. One last thing. Everyone, let's tie this. Hey, stop right now and just listen. This right here represents a length on the x-axis. This represents a length on the y-axis. Everyone agree?
Yes.
In relation to this angle, which we'll call theta, which we know is 30 degrees, or pi over 6, correct? Everyone agree? So theta is pi over 6. When I'm dealing, if I want to find this length using a triangle, let's pretend I don't have the circle here with the coordinates and stuff. If I just have a triangle, and I tell you that this is 30 degrees, and I want to find this length, and I tell you that, without using special right triangles, which, this is the key now, which of the trig functions do you use right there? This is cosine. X stands for cosine. If I want to find this length, what am I trying to find? I am using sine, and that's what we call y. When we're talking in trig, sine and cosine, we're talking cosine meaning x, a length on the x-axis, and sine meaning a length on y when you're dealing in the unit circle. So just so we're clear here, if I actually did the sine, everyone put your calculator in radians for a minute. Which means you have to switch your mode. Oops. Go to mode and go down to radians. If it's already there, great. And what I want you to do is I want you to do the sine of pi over 6. So you push sine, you find pi, and you divide by 6. 0.5. And 0.5 is right there. It is this length. Right? And if I do the cosine of pi over 6, it's that junk. Well, that junk, if you actually do this divided by that, that is that junk. Okay? This is that length. This is the cosine, in this case of pi over 6, and this is the sine of pi over 6. Okay? All right. Anyone know what tangent is? What's the ratio of tangent? It's opposite over. It's opposite over adjacent. It's what over what? It's y over x, which is what over what? It's sine over cosine. Tangent is just sine over cosine. So all these cool secrets, man, being revealed right now. So cool. All right.